Thanks for coming back again for those that have subscribed. If you are yet to subscribe, please click on the subscribe button and also the bell beside it to notify you when we drop a new video. We want to look at Taylor series, how to find the Taylor series of a given function. So if I have a function fx given a function this, the Taylor series of this function can be written as the summation of n equals 0 to infinity of the function a all over n factorial. Yeah, I will explain this. To find the Taylor series of a function, we need to choose an axis. The axis is denoted by the a. So sometimes the axis x will be taking the place of the axis a will be taking the place of x. And we're substituting a in place of x. So we have x equals a. So and sometimes if this a is equals to 0, that means x equals to 0. Then we cannot call it Taylor series again. Then we call it Maclaurine series. So what I'm saying in essence is that Maclaurine series is the Taylor series about x equals 0, about an axis of 0. When we choose the axis to be 0, then we're talking about Maclaurin series. So, but taking the axis to any number less than 0 or greater than 0, then we still refer to it as Taylor series. So we're going to look at the Maclaurin series of some function, or probably let's express this in a way we're going to understand. So the Taylor series has to do with the sum of the derivatives of the function in place of these axes. How do we do that? Let's see how we go about that. So let's take for instance, I say find the Taylor series of sine x about a equals 0. So actually this is regarded to as Maclaurin series. So we're meant to find the Maclaurin series of sine x about the axis a equals 0. So that is simple. So but when we are making use of number greater than 0 or less than 0, then we regard to as the Taylor series. So what this simply means is to find this to evaluate this formula here, what we need to do is we find the derivative of sine x in 4 places depending on the number of which you want. So if we are working because the sum is to infinity according to this formula, so because we are expressing the derivative in sum to infinity in place of these axis, how? We find the derivative of sine x, so probably we're working with 0, 1, 2, 3, 4. So if we are working with this, then firstly we need to find the first derivative of sine x, which is cos x. These are the derivatives of sine x. So the second derivative of sine x will give us minus sine x. The third derivative of sine x will be denoted by minus cos x, while the fourth derivative will be given as sine x. So having evaluated all these derivatives, then we go back to a formula. This expression means we're going to have the f of a. Don't forget, a is taking the place of x, which is the axis. So we have f of a plus the first derivative of the function in place of a all over 1 factorial, then into bracket x minus a. Don't forget x equals a, but we leave x in position, then a, which is now 0. So that will be sum with the second derivative in place of a all over 2 factorial. Then we have x minus a all raised to power 2, because we're working with this. So don't forget this. As we proceed, we have the third derivative of a in place of a all over 3 factorial and x minus a cube plus, it continues that way. So provided we're working with the fourth derivative, we perform the fourth derivative, but it's still infinity, so that we have this. It's still infinity. The sum is still infinity. So now, to find this, we found the first derivative of sine x, second, third, and the fourth derivative. So how can we evaluate the Taylor series? So we can say x. So for sine x, I'm going to use sine x. Are you following? So I will have sine 0, that is f of a, plus then the first derivative, which is what? Cos x, which is cos x, cos 0 all over. When using the first derivative, so we have the 1 factorial and x minus 0. You see this? Then we have what else? We have a plus the second derivative. So we have minus sine x. So we put that in brackets, minus sine 0 all over 2 factorial and x minus 0 raised to power 2. Then we go to the third derivative, so which gives us minus cos s. So you put in that in bracket, we have minus cos 0 into bracket x minus 0 cube all over 3 factorial. So then we go to the fourth derivative. So that's plus. That gives us sine x. So we have sine 0 all over 4 factorial. Then x minus 0 raised to power of 4 plus the terms. So evaluating this all together, sine 0 is 0. So we have a 0, which you don't need to write sometimes. So because 0 is 1, then 1 times x, so I think we have x. Then we have this is 0, multiplied by this, we have 0. Then we move to the next one. This is minus. Anyway, that will be minus, because 0 is 1. So 1 times, this gives us s cubed. So we have s cubed all over 3 factorial. Then moving to the final one, we have 0. So this is the Maclaurine series for sine x, and at the same time the Taylor series. I think you know the reason why we call it Maclaurine. So that is how to find the Taylor series for sine x about a equals 0. So we can actually test for cos x. Take for instance, that's example 2. Find the Taylor series of f of x equals cos x about a equals 0. So still Maclaurin series. Proceed with this. We use the same formula. So we find the cos x. We evaluate the cos x. I think we're working with the 4. So working with cos x, then the first derivative of cos x is going to give us minus sine x. The second derivative for cos x is going to give us minus cos x. And the third derivative for cos x gives us sine x, while the fourth derivative for cos x gives us cos x, cos x. So we have this. We can actually proceed to the next stage. So you can actually do more than this, find the fifth derivative, but we have to put it to a stop here since it continues till infinity. So from there we have the cos x, the Taylor series of cos x about x equals 0 to give us the first one, that is cos 0, plus, then we move to the fourth derivative, that is, first derivative is minus sine. So we have the minus sine 0 all over 1 factorial then x minus a, all plus, we move the second derivative, which is minus cos 0 all over 2 factorial then x minus a all raised to power 2 plus, we proceed to the third derivative, which is sine x. So we have sine 0 all over 3 factorial, then x minus a all raised to power 3. Then we have the last one, which is the fourth derivative, which is cos x. So we have cos 0 all over 4 factorial into bracket x minus a raised to power 4 plus dot dot dot. So evaluating that, here we're going to have 1 plus, this is 0, 0, let me write that. So here we're going to have minus, this is x squared all over 2 factorial, because a is 0, so x minus 0 is x all squared. So plus, this is 0, so that gives us 0 anyway. So this gives us x raised to power 4, anyway, that's plus x raised to power 4 all over 4 factorial. That's it, plus dot dot dot. So this gives 1 minus x squared over 2 factorial plus x raised to power 4 all over 4 factorial plus dot dot dot. So this is the Maclaurine series for cos x, about yes, the Maclaurine series of cos x, and the Taylor series for cos x, about a equals 0, about an axis equals to 0. So let's try the one of x greater than 0 or less than 0 using the Taylor series, using the Taylor's formula. For instance, I'm given a function that finds the Taylor series of f of x equals x squared minus 10x. Okay, probably x cubed minus 10x squared about a equals 1. So this is a typical example of Taylor series. So where we have a greater than 0 or greater than 0. So let's proceed to find the Taylor series of that function. So firstly, I think, like I've said, so let's evaluate the Taylor series for this about a equals 1. So how do we evaluate that? As we all know, following this formula, so then we still have the Taylor series for x squared minus 10x will be f of a plus the second derivative of the function into a all over 1 factorial, the first derivative I mean, then x minus a plus, we have the second derivative into a of x minus a squared equal to factorial. Then we have the third derivative of into a all over 3 factorial of x minus a cubed plus that's what we have. So let's proceed from here to evaluate that. So but before we evaluate this, we must find the derivative, the first, the second, and the third derivative. So the first derivative of x of the function will give us 3x squared minus 20x. The second derivative will give us 6x minus 20, while the third derivative of x gives us 6. So we can actually stop here. We can stop here. So then we evaluate f of a, this, and substitute all into this. So to evaluate this, we have f of a is going to give us, this is it. So we have 1 cubed minus 10 into bracket 1 squared, which is what? 1 minus 10, which is what? Minus 9. That's this. So we can also have the f prime into a, which is the f prime is 3, 1 squared minus 20 into 1. So and that gives us 3 minus 20, which is what? Minus 17. So we have the second derivative, which is 6 into x minus 20, where x is 1. So and that gives us 6 minus 20, which is what? Minus 14. So don't forget, the third derivative in a still 6. Then we can evaluate and put that into this formula, then solve out. So the Taylor series now becomes f of a, we have minus 9 plus, we have the first derivative, which is minus 17. So I'm going to have minus 17 into bracket x minus 1 all over 1 factorial. So we proceed to the second derivative, which is, so we have minus 14 into x minus 1 squared all over 2 factorial plus the third derivative, which is 6. So I have 6 into x minus a cubed all over 3 factorial, where a is 1 here. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.